In the previous video, we looked at carbon, we looked at iodine, we determined how many valence electrons. Now we're going to take and we're going to write the Lewis structure using the information or the technique that we used to determine the number of valence electrons in the previous video. In that video, we determined that we can look at carbon on the periodic table, count over from the left-hand edge, and determine that it has 4 valence electrons. And we can count the number of valence electrons on the periodic table for iodine and determine that it has 7 valence electrons. That's going to be important because the first step of writing the Lewis structure is going to be determining how many total valence electrons that we have. Now, remember that in this molecule we have 1 carbon atom and we have 4 iodine atoms. So we don't just have 7 valence electrons for 1 iodine atom, we have 4 times 7 electrons for the total number of valence electrons from all of the iodine atoms together. And if we want to figure out how many total valence electrons there are, we'll add that 1 carbon to those 4 iodine atoms, and we will know then the total number of valence electrons that we're going to have to account for in our Lewis structure. So we have 4 plus 4 times 7 is 28, so we end up with a total of 32 valence electrons. Sorry for throwing the pen cap. I get kind of excited sometimes when I'm doing chemistry, and I do love writing Lewis structures. So I get kind of jumpy, I guess. So we have 32 total valence electrons we're going to have to account for when we're writing this structure. And you're going to see we're going to use this to keep track and make sure we have the right number. Next step, after we have the total number of valence electrons in the compound, is we have to determine what's the central atom. We said in class there are 2 things that are going to help us for this particular molecule. Number 1, which atom is sort of all by itself, or is there only one of in the compound? In this compound, there's 1 carbon atom and 4 iodine atoms. There's only 1 carbon atom in that particular compound, so it is going to be the central atom. It's the one that we would predict would be the central atom. The second piece of information or evidence that's going to be useful for us is that when carbon is in a covalent compound, and remember covalent compound is a nonmetal and a nonmetal, we have 2 nonmetals here, so we know that's a covalent or a molecular compound. But when carbon is in that type of a compound, carbon is going to be a central atom. So those 2 things are going to point directly to the fact that when we write this structure, carbon is going to be in the center, and iodine is going to be distributed around that. So once we determine that central atom, we just arrange those 4 iodines around that carbon, and we just connect them each with a dash or a covalent bond. So at this point, we have put in 2 electrons for each bond, because remember that a covalent bond is a shared pair of electrons between 2 nonmetal atoms in a molecular compound. So 2, 4, 6, 8. So if we come back and look at our 32, we have now added 8 electrons that are bonding electrons. So we're going to subtract those away. We already have them in our structure. That leaves us with 24 electrons that we have to add. Now, we're going to start, once we've found the central atom, we've arranged everything around it, then we're going to look at the others, the terminal ones that we call, the terminal atoms that they are called. So the iodine atoms are going to be next. And remember that bonding occurs so that atoms can have their 8 electrons, their full octet around them. So we want to make sure when we write this Lewis structure that all the atoms end up with an octet. So we're going to start with this iodine. It's got 2 electrons around it in the covalent bond. All right, and we're going to add electrons in pairs to that iodine until we end up with 8. So it's got 2. Now it has 4, 6, 8 electrons. So we're going to stop. Look at the next one. It's got 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Each of those iodine atoms now has its octet fulfilled. How many electrons have we added? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Coincidentally, we have 24 electrons that we have to account for left. So we subtract those 24 electrons that are lone pairs. And we have no more electrons to deal with. We've added all the electrons we can. So now we've checked all the iodine. They have their octet. What about the carbon? 2, 4, 6, 8. Remember, each bond is a pair of electrons. That carbon has its octet fulfilled. So we know carbon is good. We know each iodine atom is good. We are set in terms of octet. We are set in terms of number of electrons. And so now we have gotten to the point where we have written what is a valid Lewis structure for this compound. All right? Next, we're going to be looking at things called formal charge. How do we pick if there are multiple different Lewis structures? We're going to look at a little more complicated Lewis structure problem than this coming up. We're going to be doing that formal charge as I talked about. We're also going to be looking at how do we determine what the true geometry would be. This is flat. It's a two-dimensional structure right now. What does it look like in 3 dimensions? All that's coming up in the next few videos later on in this chapter, in the next chapter.